Hi, I'm Bear, as everybody figured out. I get the nickname Bear from one of my nieces many years ago. There were three Uncle Mikes, and they decided to give us animal names. One was Uncle Monkey, one was Uncle Tiger, and I got Uncle Bear. I think that I won the lottery on that one. So my day job at CircleCI is the operations side of the site reliability engineering team. My job is to keep the site up, basically, to corral the developers and make sure everything is running smoothly and obstacles are out of their way. I've been using Python to develop applications and ops tools for many decades, and when I joined CircleCI, I naturally started to use CircleCI in my Python applications. One of the goals is to make our tool a best-in-class tool for Python, and so I started doing research to find out all the different best practices for Python testing and testing of Python web applications. The research for that goal is what generated this talk. This talk will not be a deep dive into any one area of testing. It's not going to be a battle of the frameworks. It's going to be an opinionated list of what tools and practices I consider useful for developing and deploying a modern Python web application. At the end of the talk, the goal is to have given you enough information so that you can figure out if my ideas are useful or not, even if you don't agree with them. So in order for this to be any way useful, you have to be able to recreate what I'm talking about at the end of the day. I just don't want to give you a bunch of slides and some notes and say, here, go out and do it. To that end, I created a simple Flask app that uses OpenWeatherMap, the Python module PyOWM, to return the weather for any given zip code. This will require creating a Flask code framework, an API, which also will require calling out to an external service for data, all of which will end up needing to be tested. Note that I could have created this with Django or Bottle or any of the other Python frameworks. I just chose Flask because it's a great minimal framework, which is easy to use as an example. All the code that I show here will be available at the GitHub URL bear/10key, and also the GitHub URL bear/Python testing with Flask. So anytime you're testing an application, whether it's Python or a GUI or whatever, this is the path you have to take during the testing journey. You start with developer testing, you travel and do component testing, which is web and UI testing. Then you go to integration testing, acceptance, and system testing. The line you see there is between the developer and the continuous integration division, is that the developer needs to have fast tests in order to do unit testing and component testing. The slide also points out that speed is important. The slower the tests are, the more often the developer will try to avoid running the tests. It also shows that the slower tests are done at the point in your continuous integration system where change happens less often. But the change that does happen is also more important. So you want to take the time to make sure that the application is consistent and accurate in the testing environment. So we'll start with developer testing, which is probably the most interesting part for everybody in the room. But for me as an operations person, developer testing is actually the most annoying part. But that's okay, I'm pandering to the crowd here. It's the least interesting because most developers, when they're doing their testing, will give you that standard line, works for me. So part of what I'm going to show you in this talk is how to avoid telling an operations person it works for me. Developer testing has to be fast. It generally involves using a makefile for reasons I'll show later. And this is what normally happens when developers feel that their tests are okay and they're in the wrong environment. They give you that meme that says, works for me, it's an ops problem now. What they don't know is over in the operations side of the house, they're saying this. Go ahead, one more time, just tell me it works for me. I dare you. So even if a few of these things that I show you or you follow, then we can start to head towards the DevOps Princess Sparkly future, which is what we all should endeavor to be. Sparkly DevOps Princesses is our goal. For that goal, we take advantage of a makefile. The reason I focus on the makefile is that it's a central point in the transition from a developer testing through component testing all the way up into system testing, it's the one place where you both document and also show and run the different parts that are involved in your ecosystem. It's where you can set up your developer environment. It's where you control what tests are run. It's also where you can prove that the environment, the systems, the tests are running in hasn't changed over time, or it's the same in which the makefile was created. The makefile is also useful because when you have a new developer and you want to come up to speed, you want to have the developer come up to speed, you can give them the makefile and then tell them what commands to run, and everything is documented in the makefile, and generally it's a good introduction to the system to have them go in and use it. Some highlights of the makefile. You'll see at the top I have how to clean your environment, Python manage.py-clean. That goes in and removes any artifacts that are left over from testing. Lint, test, integration test, coverage testing. The one I really want to point out is the info target. Everybody familiar with what makefiles are and what they do? Okay, good, all right. The info target is handy for when you're developing, or is handy for when you're debugging failures that have happened in the past and you're only finding out about them now. So when you're going into the past and you're looking at test runs, it fails now, but it worked then. The info target will have printed out all the versions for anything that was useful or important in the test environment. The version of Python, version of the operating system, etc. If you output that as part of your test process, when you go into the past, you look at it, you compare the versions to what's happening in the present, and if there's any differences, that allows you to narrow down what changed. And narrowing down what changed is the secret to QA. Both Django introduced the concept of a manage.py. It's a script that is used to enter into the Django environment and make sure everything is functional and set up properly in order for the application to run. Flask has a similar Flask scripts, so we take advantage of that because this is where you start the developer server, you run cleanup code. So what I did was modify Flask manage.py to also define what the classes are to run the tests, so that we can run the tests in the same manner that we also run the system. The advantage of that is we're using Flask inherent configuration management tools to also configure the environment that we run tests in. A single point of entry for everything means less bugs. We're not having a custom script in the production environment or in the developer environment. You'll find that that pattern is repeated throughout my talk. Again, this code is up here for example. A full version is in the repository. The most important thing, if I've said something is important many times, this is truly important. To make sure that the environment the developer is using on their laptop is identical to the environment that you're running in production or you're running in QA. One of the best tools to do that is called PyEnv. If you're a Python developer and you're not using PyEnv, just stop what you're doing and go learn it. It'll save you so much time. It's a virtual environment plus more. What it allows you to do is to name a Python version, set up the Python environment as that named version, and then to allow you to associate that named Python version in a directory structure. So at the top, I'm telling PyEnv to create a named Python version called 2.7.10, the Python version, anyway. And it creates it. The second set of code, I'm telling it to associate that named Python version in the directory that I'm doing my project in. And then the next one, you can see that as soon as I change it to that directory, the 10 key 27 that's in parentheses, that's my bash prompt telling me what virtual environment is active. So I get a visual indicator of what the current virtual environment I'm using is. The other tool that we use is PyTest. There are many different testing frameworks for Python. The reason I selected PyTest is that it has no implied boilerplate. It doesn't enforce any rigid structure on the developer. It allows us to create tests and use assertions as are normally written in Python. It doesn't create any special assertion methods. It also will run XUnit, doc tests, and other test formats in a standard manner. PyTest also gives us the ability to mark tests using attributes. Attributes like unit test, integration test, web UI. If back in the slide where we set up the manage.py, you'll see that the class test, that's the wrong example, class integration, the line down there that says test marker equal integration, that is actually going to get passed to PyTest to say, use that attribute to select what are integration tests. And so that's how we tell PyTest which tests to run from our manage.py. Another useful tool is a pre-commit hook. It doesn't matter how good your developer is, everybody makes mistakes. A pre-commit hook will run lints, unit tests, and other sanity checks before the code makes it up into the repository. If the code makes it into the repository, you're entering into the continuous integration cycle, and if there's a silly mistake, you're wasting machine cycles. Or other cases are developers will pull down bad code and you're wasting their time. So a pre-commit hook is a very useful tool. Python, fortunately, has a pretty good example of a pre-commit hook. The module get pre-commit hook does everything for you. You run it, it sets everything up, and it comes with a number of plugins out of the box. So you just pick the one you want and use it. You can see in the makefile, the bottom section there, install hook. I use the makefile to document and run how the pre-commit hook is installed. Again, so it's in a single location and it documents the process. In the Python world, all the tools read from setup.cfg for the most part. That's where they pull their common configuration and environment settings. So we're telling Flake 8 in the middle there to ignore all the different error codes for PEP 8 compatibility. It's like PEP 8 is the Python way of saying how many spaces do you put around variable assignments, whether or not you use spaces in front of your parentheses, different style suggestions. It also will check when it's linting whether a variable's been defined but never used, things like that. So that list of items is mostly cosmetic linting expressions that I tell it to ignore. Every developer probably has their own list, but having it in the project, again, documents it for everybody else. The bottom part you see there are markers. We're telling PyTest what attribute markers we're using in our testing suite, so that way it will be able to parse the command line correctly, and if somebody runs PyTest help, it'll actually list out the markers that are available. And it uses the setup.cfg to pull that information in so it knows what the configuration is. All right. The other half of web applications, there's behind-the-scene codes, which is what unit tests, integration tests cover. The part that probably most of the people here, because there's a couple designer-type folks in the audience, is UI and component testing. Actually using the UI to poke the buttons, enter in text into the fields, make sure everything works correctly. It's also one of the hardest things to test on a developer workstation. Generally, you have to have multiple browser windows open, or you have to have a sysadmin set up a web server to run the application behind, and then if you don't say the magic phrase correctly or give the sysadmin a bottle of beer once a week, they tend to forget to update the server. Little things like that. Fortunately, nowadays, with Docker, we have the ability to run an entire set of servers on our laptop. And now with Docker 1.9 and 1.10, Docker Compose comes into play, and it actually allows you to have multiple Docker containers all interact with each other, and you really don't need to know what's going on behind the scenes. You describe your relationship, and it takes care of the rest. If there's anything in the testing world that I consider to be magic, Docker Compose is magic. It's a beautiful thing. This is a Docker Compose YAML file. The first block is, I named it UWSGI. For those who don't know, UWSGI is a way of running a Python stack so that it can be controlled by a web server. It's just a way of running multiple copies of your Python application, and it knows the messy details of how the web server is going to talk to it. So it's not something you want to learn how to set up. It's very annoying, even as an ops person. So the UWSGI is telling Docker, I need a container, I'm going to name it that. The build period is saying that all the resources it needs to build the container are located in the current directory. And to go to the docker-uwsgi file for the information on how to build that container. The next section is web. That's going to be another Docker container. It's going to get the information from the local directory. It's going to use Docker Nginx as the set of information to build that container. The links section says that the web container needs to talk to the UWSGI container. Behind the scenes, it's going to set up the DNS entries, the localhost entries, all the little magic that it needs so that the web container can talk to the UWSGI container. The expose and the ports tell Docker that it needs to make port 8000 available to the outside world, but also to the other container. Chrome driver, and everybody should send Rob Cherry some money. Chrome driver is another Docker container. The image that it uses is being pulled down from Docker Hub. It links to the web container, and it exposes port 4444. Behind the scenes, the Docker networking stack is going to associate all the different pieces together, make sure the containers can talk to each other, and do all the heavy lifting for you. And since I love makefiles, we also have makefile targets for the build process. Docker compose build tells Docker to go out there, read the YAML file, pull in all the various pieces, get things ready. The Docker start target is how we tell Docker compose to start up the 3 Docker files, and the -d tells it to put it into the background. If we don't put it into the background, we're not going to be able to run our tests because it's going to be taking control of the foreground. The web test target, we tell it to run Docker start, and that wait for IP is a shell script, which is an interesting hack. Docker on OS X and Docker on Linux expose the IP address for the Docker machine in different ways. On OS X, it's using Docker machine to allow the Docker stack to talk to the OS X for resources. So Docker machine is the one that's doing the hypervisor layer, if you're into Docker. It only exposes one IP address, and that's it. And it knows by port number and other configurations how to get to the different containers. On Linux, each Docker container has its own IP address. So there's different ways of getting that information. Inside of wait for IP, it figures out the operating system and then looks up the IP address it needs based on which OS you're on. And then it waits for the exposed ports to become available so that it'll actually wait for your web server to start and properly and to be running, and then it'll continue on and run our tests. And you see we're running Python manage.py web test. So we're using our start script to go out and do the environment to start the tests. And then we're done, we clean up. I told you about UWSGI being evil, and that's one of the reasons is it's hard to configure. The advantage we have on using Docker is once we've learned that configuration, either the operations person can help the developer configure the web server, or if the developer knows web servers, they can set up the configuration, and this is the Nginx config that will be inserted into the Docker container. The reason I'm showing it to you is that here is where we start to show the documentation process on how this application needs to be run, and we can hand that off to the operations team. They no longer have to guess how your web stack is run in production. The information that's in this configuration file gives them a lot of clues as to what's required. The first section up there is an upstream. That's Nginx speak for the web server will be going to another application or server in order to satisfy the web request. A proxy forward it's called. The server section tells Nginx, how do I start up as a web server? It's going to listen on port 8000, and the server name underscore means use the host name for the server name. So that way you can have a local DNS entry. You don't have to worry about having a local host entry for like test.com pointing to a local host. That bypasses that problem. Because we've set up our Docker environment, we now have an environment that's exactly the same as will be used further downstream in testing. That gives us a lot of advantages. That means that when we're done with our testing and everything is okay, the first line, we can bundle using Git archive the application without any of the Git bits into a tarball and release that as an artifact of the testing environment. So if your application needs to be used as an external resource for another part of your system, you no longer have to give them Git credentials. You just point them at the last tarball that was created that passed the test. And so I just showed an example of that using Git archive. There's many other ways of bundling up applications. If you're in the Node.js world, there's different tools for that. That line there, just to show you why I call UWSGI evil, that's the line to start UWSGI and to run a Python application behind the scenes. Don't ask me what it does. I copy it and paste it every time. It's worked. I don't bother trying to figure it out. The bottom part is very similar to the manage.py. It just changes the application variable so that UWSGI can find it. That's just an example of that. We're almost done. Once we get artifacts from our test and building, we're now ready to deploy. Because we use Docker for all of that, we know with certainty that our test environment is sane and accurate. The deploy step is just a matter of finding out what the commands are to push it to App Engine or to push it to Google Cloud or to send it off to your ops team. And we have quite a good example of how to do deploys on our doc site. So I wanted to show you how easy it was for that. Other resources if you're testing with Python is Tox. Tox is a way of running your Python tests with multiple versions of Python. You tell it, I think I have that here. Wait, nope. You tell Tox in the INI file you want to run Python 2.7 or Python 3.5 or even PyPy. It will actually take your application, set up a virtual environment for each of those versions, and then run those tests in those versions. You don't have to manage anything except telling it what versions you want to run. Very useful for acceptance or system testing to make sure your application will work in those environments. I wouldn't consider it for integration testing because it can slow things down. Another useful tool is coverage. Coverage.py will actually shine a light into the dark corners of your code to show you the areas of your code that aren't being executed. It'll also show you the areas of the code that are being executed, which means what your code coverage is for testing. The reason that's good is that any area of your code that isn't being executed is a future bug. Because it's not being covered by test, that means it's sitting there and it hasn't been looked at. It's a bug waiting to happen. You should remove that code and add it back later when you know you need it. Mock, and if you look in the repository, there's actually an example of using mock in where I test the OWM API. Mock is a way in Python of replacing an external resource with a call and response object that you can actually store what the response should be. So when your code is calling out to the external API, it'll insert itself and say, I'm that API, and this is the response you get. So that way you don't need a network connection to your tests. And you're also not hammering some poor server with your test 20 times a minute because you're running your cycles. So mocking is a good thing. Fortunately, in modern Python with the Python library requests, mock and request play well together. They're really simple to set up, so it's a good thing. Locust.io is a load testing tool, also written in Python, where you describe how you want your application to be tested as if multiple users are targeting it. And the configuration is written in Python, so it's easy to use. Locust.io is actually a very good tool, and it's used in a lot of high-end production environments, but also something that a normal developer wouldn't use. The 3 links that are there are good resources for Python testing by people who have been doing it as long as I have and are much better at it. All right, and that's it. If you have any questions, a good place to reach out to me is at the CircleCI Discuss board, so that way I can answer, or one of our many good support people can answer, and there's the repo where it's at.